Welcome to Onshape for Makers, where we are learning to make models to take to the shop. Today's part is a bit chuck. It is from the Too Tall Toby website, where he has all kinds of models to practice, speed modeling contest, many training videos. There's also a YouTube channel that goes with the website. Both are a treasure. You need to go visit them. It's amazing what's over there. This part is a bit of an interesting part. There are several ways to do it, but we're going to look at a way to do it to make it as simple as possible with as little work as possible. The features in this part are basically just a hollow tube with a slot in it and a hole that goes halfway through one side. The problem is when you draw it, if you start at the origin, 2 circles extrude will give you a tube. But then you're going to have to either construct on the center inside the part, or you're going to have to offset a plane to do a construction to form this slot. You can do it from the top and push the slot down. You can do it from the side and do a extrude remove through to cut the slot. Either way, if you start that way, you're going to end up with a construction plane. Then you come to the hole. The hole only goes halfway through, so we have to build a construction plane out here, make a circle, and push it to the center. Or we can draw on the center and push it out. Either way is going to be a bit of a problem. Let's go over to Onshape and let me show you a third and much easier way to do this. Okay, we're starting in a new part studio. In the hamburger menu, the workspace units, millimeters, 1 decimal place. Under mechanical mass, we'll go to grams with 2 decimal places, green check mark, and we're good to go. Now, if we start on the top plane for our first sketch, normally we would just do a Shift S to get into the sketch mode, and we would come out here and we would pull a 20 millimeter circle. And then we would pull a 12 millimeter circle, which is the inside. And we would save that and do an extrude of that, and we would do it up 20. And that would be our first part. Now, the problem we've got is to get this slot, we have either draw on this surface or offset one of these ordinal planes to get to where we can draw a slot. The other option we've got is much simpler, but let's wipe all that out and I will show you a different way to do it. We will start on the top plane with a sketch, and we will draw the circle off center. We'll pick a spot anywhere, pull to the origin, click, and then type 20, and that will set the center to where you want it. Pick 12 from the center. Now, we're going to draw the slot while we're here, and the easy way to draw the slot, instead of drawing parallel lines and all that, is simply go up here to the center point rectangle tool, catch the center of the circle, pull up, pull out, and click. If you hold your mouse at the bottom, you can type in 4, which is the width of the slot, and then it will highlight some number to the size of the slot. You really don't care, just hit enter a couple of times. It will turn black and everybody will be happy. Now we can close the sketch. We can go to extrude. We can pick the 2 halves of the circle, plus this part, and go down. I will show you why we're going down in just a second. We're going down 20, and that is our part. Now, if we re-enable the sketch, we can simply do this and that, do an extrude, do a remove, and the distance for that is 12, and we're through with the slot. That's all there is to the slot. If we go to the 1 millimeter chamfer, we can touch this edge, that edge, and we have our chamfers finished. The only thing we like now, let me turn off this sketch to get it out of the way. The only thing we lack is this hole. It just so happens that the right plane is tangent to the side of that because that's the way we drew the first sketch. So we're going to go sketch on the right plane, do a normal. We'll zoom in a little bit. The size of the hole is 4 millimeters, so we'll set the center line, pull out, type in 4. Now, this is an interesting discussion. Do we dimension from the top or the bottom? Well, the engineer has chosen to dimension from the top, so we can assume that the critical dimension for this hole will always be 5.5. That way, if the top grows, if he makes a longer part, the hole will follow it up because the critical dimension is always to the top rim. So now that we have the sketch, we can close it, we can go back to extrude, we can select remove, we can pick the hole, and you'll notice it goes all the way through, but we can prevent that by changing blind to next. What that means is it will go through the first side, which is this side, and it will stop before it comes to the next surface, which is this side. Huge advantage here. No matter what size this bushing is, as engineering changes it, we will always have a hole only through one side, and we never have to worry about either the hole not going all the way through or the hole going through the other side, because it's now dependent on the other geometry. That's the advantage of parametric engineering as opposed to what you and I would probably call regular engineering or discrete components or whatever. Anyway, that's the quick way to draw this part. I hope that made sense. You guys have a good one.